Thank you everyone very much for your patience and time. Um, I'm just going to start, in fact, by showing a QR code. I'm aware that obviously this is a Fedora session, but those of you who do use Hyrax, this is all of the Hyrax code we used to make this work. So if you go to this, um, this is all the code we used, and it is quite an old Hyrax. We are using 251, but I think it's a real and optional demonstration of actually how we got the code across. So let me begin by doing a little presentation. If I can get to here, it's not letting me click anything. Can everyone see those slides? Is that big enough? And I can just migrate this because I can't seem to actually go to any of these buttons that I'm clicking.
We can see them. We got
Good,
the
fine.
visual.
So, and there's nothing compromising in the things. So what this presentation is, it was delivered at Open Repositories, is talking about the data preservation service that we built for ORA on Fedora 6. And it talks a little bit about how we did it, some of our priorities, and actually what it looks like under the hood once we've done it, and how it integrates with our Hyrax system. So ORA is the institutional repository for the University of Oxford. We started in 2006. We have over 300,000 digital research objects. That's quite a variety of objects. We have journal articles, theses, data sets, and working papers, grey literature. Our public website is at ora.oxarc.org, and we are currently the fourth generation of ORA, which is built on Samvera Hyrax 2.5, and we use Fedora 4.7 for storage. And Fedora 4.7 had some real problems for us. The biggest problem with Fedora 4.7, beyond even performance, is the fact that object level metadata is not preserved on disk in a performant way or in a way that works well for digital preservation. There is no functional backup of a Fedora 4.7 Hyrax object without basically saving a mode-shaped database, which we have no interaction with. So one of the things that our digital preservation team identified was that we needed a way to store our objects, binary files, and metadata in a co-located way that followed digital best practice. We also wanted to store versioned objects. Those of you who are familiar with Hyrax will know that Hyrax doesn't really understand object level versioning. Whereas for us, especially things like data sets have a concept of a version. You can have the 2000 version of a data set and the 2002 version of a data set, but they're conceptually the same data set. So we didn't want to keep creating new objects for every single version of a data set. We wanted to be able to create versions somehow within our system. We wanted very much the data storage to be application agnostic. And we also wanted it to be application agnostic in a way that allowed our digital preservation service team to be able to interrogate, profile, and analyze our binary file content. So that's what we were looking for. And the decision was OCFL. And I want to kind of highlight this from the start, that the data preservation service, as we see it, is the OCFL layer. Fedora, for us, is our management layer. It's how we get stuff in, get content in. It's how we get content out. It offers us an awful lot of things, access control. But the DPS, as we understand it, is the file system on disk. And yeah, we use a Fedora 6. We're using version 6.5. repository using archival groups as an API layer to manage an OCFL file system. This is a rough map of how we do this. Just to give you an idea that we really wanted something that was strongly decoupled. So we wanted to be able to move the DPS both geographically. We didn't want to have to co-locate within any specific storage center. And we also wanted, if necessary, to be able to separate it from any of our underlying hosting providers within Oxford. If we wanted to take this and put this in someone else's system, because everything at Oxford is hosted on-prem within a virtual cloud within Oxford. But we wanted that ability to fully decouple the DPS. We did at one point, and this is just speaking back to Rob's presentation, have the idea that we would mount our binary files alongside the OCFL storage route and then tell Fedora to copy those across. But it turned out actually that Fedora 6 was performant enough in copying even our largest files. We've moved now 322 gigabyte file in 40 minutes, which is well within any of our performance spec spacing, all just using HTTPS to move the files across. From a development timeline, in a way, it took a very long while. It took 18 months for us to come up with this solution. But almost all of that was scoping and requirements gathering. It took, and we did an additional 4 months of Fedora 6 performance testing and configuration. Fedora 6 testing code, which is linked in the QR code, meant that even before we began our migration into the DPS, we had created a mock DPS and fully populated it with all our code and stress tested it. This was basically because of our experience with Fedora 4.6. We wanted to know that Fedora 6 would perform. And to be honest, we didn't manage to break it. Not merely did it perform, but we didn't manage to break it. So we spent quite a long time doing testing and configuration. But actually, in terms of when the project brief was signed off in August 2023, we had an end-to-end code solution by October, including full integration with Hyrax systems, full deployment of the DPS. And then from there, we had full population, in fact, within only a few months. So we spent a long while being sure it was what we wanted, but by the time we got there, we were very pleased with it. Now, what I have now, let's see if this works. Can everyone follow along, by the way? Everyone can see this. Thumbs up, no thumbs down, brilliant. What we have now is actually a walkthrough to show you how it integrates within our Hyrax system. This is an object within ORA. It's a journal article. This is one of our fancy journal articles in that we created it automatically from publications router. It wasn't deposited by a human. And this is a fairly standard Hyrax interface. What we're going to do with this object is we're going to save it in the DBS. We're going to create some versions of it, and we're going to see how they look on disk. So one of the ways you can preserve it in the DPS is simply to click on Preserve in the DPS. And if you do that, a message is sent, and this is the object that is created. So it's an archival group. We have 2 binary files that all of the metadata, incidentally, I should stress, and I'll just pause it very quickly, and you get a sense of all of the horrible things I watch on YouTube. We don't use Fedora triples to store ORA data. All of the ORA application data is wrapped up in JSON files or XML files and persisted in the Fedora 6 as a binary file. So we only use Fedora metadata for object management. We don't, all of the ORA application logic is put away. So what you can see here is a saved version of an ORA object. We have a metadata file, which is at metadata.json. We have a public version of the metadata, which we use to package up. If we ever need to side load out public versions, then we can use that. And we have the binary file preserved there. Those of you who are familiar with Fedora 6 will know this is roughly what an archival group looks like, what an object looks like when stored in Fedora 6. This then is how we preserve our metadata. We just convert it into JSON and crosswalk it across. This process is staggeringly quick. Exporting an object from Hyrax into the DPS takes about 1.5 to 2 seconds, whereas it takes about 28 seconds to save the same object in Fedora 4. I'll give you an idea of how performant this approach is. This is the object on disk. So you see, actually, again, it's a very clean save. We simply have a content directory. We have one file which we've chosen to ignore, fcrcontainer.nt, and then we have 3 files, 2 metadata files, and 1 binary file. And that's stored on disk. What we've done now is I've added another binary file to this object. And instead of doing the manually sending it to the DPS, we've integrated send to the DPS within our Hyrax actor stack. So if I republish this work, and I just select republish, republication automatically sends a new copy to the DPS. You can see that the live version of this now has 2 binary files. And that's obviously very powerful for us. It's very useful for us. That all of the DPS saves simply happen automatically within the back end. And we have, for this object now, 2 historic versions of it, which is, again, it gives us the ability to navigate back to the previous version. This was a demonstration for people not familiar with Fedora, that you can navigate back to a previous version. And again, this is the new version of the metadata with these with changes in place. And this is the object on disk, and I'm just going to pause it here. So you can see that we had the first version, and the second version, again, it's extremely clean, extremely simple. We have new versions of the public metadata, new versions of the metadata, and a binary file. So the structure for us is extremely clean, extremely logical, extremely straightforward. We are also able, using the Fedora API, to put together downloadable zips of previous versions of objects. So we're able to ask for a point in time object from Fedora 6 and send that to end users on request. I'll go through the other stuff very quickly. In terms of what this has given us, perhaps beyond the initial requirements, it's given us a really centralized and context agnostic and traceable way of looking at our binary files. And our metadata. We didn't appreciate until we did this how difficult it was for us to get from a file on disk as reported by our digital preservation service back to a real object that we could look at and understand. And the way in which files are co-located on disk enables us to do this. It's really helped our virus checking, in fact, because it's enabled us to use different sets of virus checking tools. We obviously have metadata is now a first-class citizen within the system. It's preserved properly. And the other big benefit now is that this is migration-proof data. We have documented how these structures are, and we expect the DPS to be the data store that powers the next version of ORA. We may never do an export from our Hyrax interface again. We'll simply load back out of, or teach the new system to read from the DPS. And some numbers. Actually, when we decided to do the full population, it took 12 hours for us to resave our entire repository, which was by at least one order of magnitude quicker than we had expected. We'd budgeted a month of work in order to populate the DPS, and simply we ran a batch of 1,000, we ran a batch of 10,000, then we thought, heck, we ran a batch of 50,000 and then 100,000. We were just sending stuff in and through, and Fedora 6 was swallowing it extremely well. We made, during that process, about 2 million API calls. I don't know, because we don't use the cloud, how this would translate to an S3. This is all on-prem storage. but it gives you an idea of the scale of what we did. We created 1.6 million distinct files in the file system. 8,000 of those were metadata files, and a quarter of a million of them were binary files. Since then, the actual usage has dropped like a stone. We push about 3,500 objects to the DPS, about of which 1,200 are new a month, and that works out at only 17,000 API calls a month. So if you were looking at running a similar solution like this in the cloud, I would strongly expect that it would cost that almost all the expense would be initial population, although I think everyone here probably understands and appreciates that. And then, yeah, for full disclosure, this gives you an idea of roughly how big what we had was. We had a RHEL 7 box with 12 CPUs, 32 gigabytes of RAM, and 8 terabytes of Dell compellent storage sitting underneath it. And thank you very much. Thanks particularly to Cottage Labs, who provided, they were our external consultants for many of the processes here. Yeah. For more links and resources, I will put up again the QR code.
Thank you very much, Tom. Are there any questions from the room? I can't see any in the Q&A from within Slack. Sorry, from within Zoom. Just going to Slack.
So I can see one question from Emily.
There's one in the chat here now, yeah.
So we are using Fedora 6 with Hyrax 2.5. But as far as Hyrax is concerned, what our Hyrax code does is it takes the Hyrax metadata, turns it into JSON and saves it as a JSON file, and then it exports the binary files. So we have, it's very, very lightweight code, apart from the turn a Hyrax object into JSON. That's quite a bit. The metadata crosswalking is significant, but the actual DPS code is extremely light. We use a piece of Ruby code called Fedora 6 Client, which we wrote for the purpose, and which we've also shared.